Okay, so now we're going to take a look at some of the calculations using measured numbers and then applying some of the rules for significant figures doing these different types of calculations. So the rules are slightly different, whether we're doing addition, subtraction versus multiplication, division. So let's take a look at addition, subtraction first. So the rule is if we add and subtract, add or subtract, the answer cannot have more digits to the right of the decimal than any of the original numbers do. And a good way to try to visualize this pretty quick when you're actually doing these is to rewrite the numbers and then simply line up the decimal points. Okay, so if I have 102.50 added to 0.231, if I rewrite these and I line up my decimal points over here, I can see that the 102.50 has 2 digits after the decimal, and the other number has 3 digits after the decimal. So that means my final answer that I get, even though my calculator is spitting out 102.731, I need to round this to 2 decimal places or 2 digits to the right of the decimal. So I go to those 2 places. Next digit is less than 5, so I keep the 3 here as it is. So this rounds to 102.73. Same rule applies for subtraction. So if I have 143.29 and I subtract 20.1, line up my decimals. Okay, I see then that the 20.1 has 1 decimal place. The other one has 2 decimal places. So my final answer then, even though my calculator gives me 123.19, I need to round this to 1 decimal place, right? So the next digit, the 9, is 5 or above. So I round the previous number up by 1, or the previous digit up by 1. I end up with 123.2 as my final answer. Okay, so that's the rule for addition, subtraction. Sig figs. When it comes to multiplication and division, the rule is slightly different. We look at the number of significant figures in the numbers that we are multiplying and or dividing. And we take the least number of sig figs in any of those, and we apply that to the final answer. So for example, if I have 1.4, which has 2 sig figs, and I multiply it by 8.011, which has 1, 2, 3, 4 sig figs, that's a confined zero. That's significant. So I have 2 sig figs, 4 sig figs. My final answer then should have 2 sig figs in it. Even though my calculator gives me 11.2154, I need to round this to 2 significant figures. I start at the left, work my way across. That's my first, that's my second. The next digit is less than 5, so I keep the previous digit as it is. This rounds to 11 as my final answer. So when you do these types of calculations and you stick them in your calculator, don't just replicate all the digits that the calculator is providing, is spitting out to you. Apply the rules for sig figs, okay, because they are going to be important. The same rule we use for division. So 11.57 has 4 sig figs divided by 3 or 5.88. That has 5 sig figs. So whatever number I get, that needs to round to 4 significant figures, right? So I have my calculator answer. I'm going to round this to 4 sig figs. So I start from the left to work my way across. The 3 here is the first sig fig because leading zeros are not significant. Even if there's a decimal point in the number, leading zeros, when there's no other non-zero digit ahead of them, leading zeros are not significant. So the 3 is the first one, the 7 is the second, 8 is the third, and the 2 is the fourth. Okay, so those are my 4 sig figs. The next digit is 5 or above, so I round the 2 up by 1, so I end up with 0.03783 as my final answer. When we have combinations of measured numbers and exact numbers in the calculation, we need to consider one important thing. Your exact numbers, you can think of those as having an unlimited number of significant figures in them, or an infinite number of sig figs. So as a result, they are not going to limit the sig figs in your final answer. okay? As an example, if we're told that 3 pennies each have a mass of 2.5 grams, and we need to figure out the total mass of all 3 pennies, well, what we're doing here is we're multiplying 3 by the mass of each penny, which is 2.5 grams. Now, the 3, the number of pennies here, we get that by counting, okay? And if you recall, when you get a number by counting, that is an exact number. So that has an unlimited number of sig figs. So it's not going to limit. So will not limit the sig figs in the answer. So what will limit the sig figs in the answer is the measured number in this case, which is 2.5. That has 2 sig figs in it. So then my final answer must have also 2 significant figures. So keep that in mind when you're doing your calculations. Are you dealing with exact numbers in addition to inexact ones, or are they all inexact? If you have any exact numbers in there, they will not limit your sig figs. You can focus on the inexact measurement to determine how many sig figs you have in your final answer. And the last thing we'll take a look at here for the strategies in dealing with sig figs and calculations is when should you be rounding? Okay, so the temptation would be if you have multiple steps in a calculation, you may be tempted to round after each step. What actually that does, though, is it introduces rounding errors, and then your final answer, depending on the number of steps that you're doing, your final answer may be off by quite a significant amount. So ideally, what you want to do is you want to round at the very end of the calculation to reduce those rounding errors. And what we can do, what you need to do then in order to do that, is you keep extra digits throughout each of the steps as you go through the calculation. So for example, if I'm multiplying 3.66 times 8.45, okay, if I round after that first step, I end up with 30.9. If I don't round, I have 30.93. Okay, according to the rules for sig figs, I have 3 significant figures, 3 significant figures. So whatever number my calculator gave me, I rounded it here to 3 sig figs. Here I'm keeping an extra digit. This 3 is extra. What you can do to help you sort of keep track of how many sig figs you need to have in the final answer is you can put a little line above the last significant digit, right? So we know that this number here needed to be rounded to 3 sig figs. I can put a little line right above the 3rd sig fig. And then I do my second calculation. So 30.93 times 2.11. This also has 3 sig figs. So again, the number that I get at the end should have 3 significant figures, and we can round it appropriately. If we rounded after each step and didn't take that extra digit with us, then the number is off, in this case, by 1/10, right? 65.2 versus 65.3. So generally, keep at least 1 extra digit until the end of your multi-step calculation. You will avoid those rounding errors throughout that process. So let's take a look at a couple more examples. So let's say we're dealing with, let's do a, let's do the multiplication. So the 6.25 times 1.175 centimeters. So this is a multiplication. First number here has 3 sig figs. The second one has 1, 2, 3, 4 sig figs. You stick that in your calculator. This is what your calculator gives you. Okay, do not write that as your final answer. You want to round this. And according to the rules, we're going to round it to 3 significant figures because that's the least number of sig figs in our in any of the measurements. So we round to 3 sig figs, 7.34, right about there. Next digit, less than 5, so we keep the 4 as it is. So that rounds to 7.34 centimeters squared. So in some problems, you're going to be given not just strictly addition or subtraction, or not just strictly multiplication and division. In some cases, you're given a mixture of different types of operations. So how do you approach those types of problems? Well, you want to approach them the same or in a similar manner where you keep track of your sig figs along the way, but you keep an extra digit so that you're rounding only at the very end. So let's take a look at this example. So it says an empty container has a volume of 9.85 times 10 to the 2 cubic centimeters, is weighed and found to have a mass of 124.6 grams. Container is filled with gas and reweighed. The mass of the container and the gas now is 126.5 grams. Determine the density of the gas to the appropriate number of sig figs, right? So this is like a word problem. We need to extract the information that's presented in it. So just like with the examples we did previously, we want to organize the info. Okay, so what are we given? What do we need? Then hopefully that will help us figure out what we're going to use to get there. So the very last sentence usually tells you what you need to calculate. So we need to calculate the density. We saw density before. Okay, so in order to calculate density, D is equal to the mass over the volume. So are we given mass? Are we given volume? Well, the first sentence provides us with the volume. So volume V is equal to 9.850 times 10 to the 2 centimeter cubed, or cubic centimeters. Are we given the mass? Well, we're not told explicitly what the mass is, but we know what the mass was of the container empty, which was 124.6 grams. And we know the mass of the full container when it's filled with the gas as 126.5. So if we want to figure out the, so we need the density of the gas here, by the way. So we want the mass of the gas divided by the volume of the gas. So we're given the volume of the container, which is the volume that the gas will occupy. And we're told what the mass of the empty container is. We stick it, we put some gas in there, we fill it up all the way, and we have the mass of the full container. So then the mass of the gas would simply be the full mass minus the empty mass of the container. Okay, so we have 126.5 minus 124.6 grams. So we subtract these and we end up with 1.9 grams. And according to the rules for sig figs, each of these has 1 decimal place. So this final answer then should have 1 decimal place. And there really isn't any other digits to the right side that we need to round. So this is already the answer. So this has 1.9 grams is our mass, which by the way now has 2 significant figures in it. And we're going to take that and we're going to divide it. We're going to stick it into our equation and divide it by the volume. So the volume is 9.850 times 10 to the 2 cubic centimeters. So this is my number expressed here in scientific notation. In the denominator, that's the volume. And when you have your number in scientific notation, we just look at the coefficient. That is going to tell you how many sig figs you have in the measurement. So we have 1, 2, 3, 4 sig figs, right? And now we're dividing these two numbers. We have 2 sig figs on top. We have 4 sig figs in the denominator. So my final answer then, whatever I get, needs to be rounded to 2 significant figures. So I stick that in my calculator. I get 0.00193 gram per cubic centimeters. I'm going to round that to 2 sig figs. So I start on the left, work my way across. Leading 0 is not significant. So I get to my first significant digit, which is the 1, and then the 9 is the second significant figure. The next digit less than 5, so we keep the 9 as it is. So this then becomes 0.0019 grams per cubic centimeter.